Parallelogram with sides is the rectangle. Check the Pythagorean theorem, which is for right triangles only. So this is just a way to make sure that the Pythagorean identity works with vectors. So let's see if this is true. What's the length of V? The length of V is just the magnitude of the vector, which is the square root of the sum of the squares of its components, or to say it differently, it's the dot product of the vector with itself. So this would be 4 times 4 plus 2 times 2 to get the magnitude of V, or 4 squared plus 2 squared, so that's 16 and 20. This would be 2 root 5. Okay, and then similarly, W, the length of W would be minus 1 squared plus 2 squared would be 5 plus 1, 6, so square root 6. Okay, now what's the length of V plus W? Well, first we add the two vectors. The sum of two vectors will give us a vector. So V plus W will be, we add the corresponding components, so 4 minus 1 and 2 plus 2, so that's 3 and 4. Okay, and now we get the length. I could have, since we need the length squared, I could have squared here and got rid of the square root in one step, so this answer would be 20. And same thing here, this takes care of the square root, and the answer would be 6. Okay, so V, going back to V plus W, so V plus W length squared will equal to 3 squared, oh sorry, this is 5, plus 4 squared. No square root since I'm squaring it, so 9 plus 16, which is 25. So and what's V squared, length of V, plus length of W squared? That's 20 plus 5, that's 25. So indeed the Pythagorean identity holds, and the length of V squared plus the length of W squared indeed is equal to W plus V length squared. That concludes it.